In this video, let's concentrate on creating a filled surface to finish off some of the area of our hand grip. So as you can see from the last time, we created several boundary surfaces to help drive the shape of our turn signal area. Now what we need to do is create a filled surface to create the rest of the surfaces in this area. Once you select filled surface, you can right click on one of the edges, select open loop, apply to all edges, and use a curvature relation for the edges. Then I'm going to deselect apply to all edges. Then I'm going to go back to our curvature 1 we used to select the edge. And remember that when we created our boundary surface, we used a 10-degree tangency. So for this one, I'm going to use a contact relation. You can see that gives us a very different result. And this allows SolidWorks to do the math behind the scenes using our curvature relation with this edge and our curvature relation with this edge, and carry on the 10-degree tangency and blend it smoothly into the rest of the geometry. So let's hit OK. As you can see, the result is nice and smooth. Our curvature is carried in nicely to all the surrounding geometry. I'm going to go ahead and knit this to the surrounding surfaces. That way we have one created. So you can see that blend worked rather nicely. Everything worked out well, and the tangency is carried on through all the edges. It's very important when you're creating these filled surfaces, if you use something like that 10-degree tangency here, to make sure that you understand when you apply relations, it's going to try to override that and introduce a lot of tension into the surfaces, especially in this corner. So it's important to remember what you did, when you did it, and why you did it. Let's follow the same procedure for this other open section. Use a filled surface, going to right click, select open loop, apply to all edges, using the curvature relation, and then deselect that option, grab that first selection, and use contact. So as you can see here, that removed a lot of the stresses in the surface. Just so we can see what's going on, I'm going to put curvature relation back on and take a look at the preview. So as you can see, the geometry created in this corner, where we have a 10-degree tangency, but we're trying to use an equal curvature relation, is introducing a lot of tension into this surface, and ultimately we're getting a very bad result. So we want to make sure we use contact in that corner to allow SolidWorks to blend everything smoothly together without trying to create any extra relations to this edge. Hit OK and take a look at the results. Again, that's a nice smooth blend. I'm going to go ahead and knit that together. I do want to mention one more thing. The process we use by creating these boundary surfaces and letting the surrounding geometry drive the curvature is a great one to use, especially when you have very little information about the surfaces you're trying to recreate. Allowing the surfaces to induce the curvature is going to reduce the amount of error you create inside these surfaces. If we were to use guide curves along the edges and then try to create relations with the edges of the surfaces, we might induce a lot of extra stress inside of our surfaces. Because we're dealing with SolidWorks, a parametric modeling program, we don't have complete control over these surfaces as if it were a complete free surfacing program. So it's important that you don't try to over-define your surfaces. In this case, because we have very little information about the surfaces we're creating, it actually gave us a little bit of extra freedom. The process we're going to follow for the bottom is the same, with the exception of needing to blend everything together with a turn signal area. So what we can do now is create some surfaces from here to here. And again, we can drag these endpoints and we can create some geometry. We're going to use a tangency to face relation with both edges and take a look at the result. As you can see, this is a nice gradual bend, and because we don't have images in the area of concern here, we're going to go ahead and assume that this nice gradual surface is going to be a good representation. So we're going to hit OK. We're going to knit these together to make our edge selections easier. We're going to create one more boundary surface. I'm going to go from here to here, and notice that the handles are actually crossing. So by right-clicking on Edge 2 in our Direction 1 box, I'm going to flip connectors, drag the handle endpoints, because remember, we're just creating a small helper surface here to help drive our geometry. Then with the edge where it blends into our steering wheel, we're going to use a curvature to face option. And the edge on our boundary surface, we're going to also use a curvature to face option. And notice what this does to the surface. So once the surface is satisfactory, I'm going to go ahead and OK that. I'm going to knit everything together again. Then we're going to use that filled surface option. This time we're going to right click, select open loop, apply to all, and use that curvature relation. We don't have to remove the relation from one of the edges because we don't have a 10-degree off tangency. So we can just simply OK that, create another one on the right-hand side, select open loop, apply to all edges, and use a curvature relation. All right, now we can knit everything together. Notice that we have a gap in this one, so we can select the gap to seal and hit OK. The last thing we need to do is fill in this open section here. Again, I'm going to use the filled surface. I'm going to right click, select open loop. And because I know that all these were created on this flat surface here, I'm not going to add any relations. I'm going to simply hit OK. I'm going to knit this together. Again, we're going to seal the gap and hit OK. If we take a look at this from the front, we have most of what we need to help define our surfaces. There's still a few more details we need to add. That's better saved for another video. This concludes creating filled surfaces to blend our steering wheel sections.